I will divide this video in two different videos. One will explain the theoretical concept of the program along with some basic knowledge of MATLAB. Second video will explain the code inside. Okay, so let's start with the basics of MATLAB. I must consider that you are you are aware of the basics of MATLAB, yet a brief overview will be better for both of us. So as you know, MATLAB works in column format. If you have to, it works in matrices. Whatever you will input, whatever you will get the output, that will be in the matrix form, and the operations, every operation performed by the MATLAB will also be in the matrix format. So let's start with the example of definition of a matrix. Consider we have to define a matrix of 2 by 2. Then you just write here as in the screen 2 3. This is the first row. For the second row you have to put a semicolon and 1 and 3, and then just press enter. You will get a matrix of 2 by 2 here, as you can see. The desktop of MATLAB is consisting of a current directory where your all present current files are placed, an editor, a command window where you can check any command, or you can edit or display any kind of variable. This is a workspace where you will that will display the values of all variables here. Like I have defined A as a matrix, so that A is also present here. You can check it on double clicking the variable name, and you will get an Excel file opened like this. Yeah, this Excel file here, MATLAB provides you freedom to change the value of any column or row. Like I have changed it from 3 to 5. So if you will check A here in command window, you will get a changed value. So although this is not required in any kind of script writing, but this is a functionality that MATLAB provides. Okay, and all kind of matrix operation which are performed in mathematics are also possible in MATLAB. Like if you want to multiply the matrix A with a number 2, then just do like this, a dot that represents the multiplication of element wise multiplication sign and the matrix. If you will put enter, every element will get multiplied by the 2. Here is the difference. Like if you are not putting the element wise operation, like I just multiplied 2 and A here, then what we will get? We will get only the first element multiplied by 2. Rest are same. We will get the every element multiplied by 2. Like if I define another matrix 3 4 of same dimension, now if you want to multiply A and B, what you will have? 2 3 4 1 5. Okay, can you check out this, how it is multiplied? So this all operations are similar to the mathematical operations. The one thing is that MATLAB works in columns. Like if you have defined A, now A is this. If I ask you what is the second element of this matrix, in our general aspect we will say that 3 is the second element, but in MATLAB read the 1 as the second element. Like here MATLAB counts in columns. Whatever operation you will perform, that will be in column format. Okay. So now as in our work, we have to tune the system with the help of genetic algorithm, so that the cost obtained is minimized. Like the paper has described the objective function itself, which is considering the 4 kind of quality of service parameters, and the fitness function is defined here. The fitness function states that it is the sum of weights and quality of services plus weight multiplied by distance between services. Distance between constraint and distance is defined here. The quality of service multiplied by the EI. EI is the factor which represents either this service is connected to any node or not, and weight is the this. Here this weight P is the penalty factor, and this is the weight which helps to sort out, which helps to avoid it for the local conversions. Okay, so in MATLAB we are having a genetic algorithm toolbox, and we have used that toolbox that removes our hassle to write the code from the scratch level. And here you can see, I show you the system. Yeah, this is one is the toolbox. The toolbox provides a direct function which helps us out to implement it directly, like in this GA. If you want to see the functionality of GA and how the syntax of GA works, you have to press F1. Then a help file will pop up, and that will describe everything about the GA, the function which we are using, what is the input to this function, and what kind of output we will achieve by using this function. So as far as the terminology, chromosomes, mutation, crossover, these kind of terminology are avoided in this toolbox, because user need not to deal with terminology, because we are not writing the code from the scratch. We are enjoying the MATLAB's freedom. MATLAB has provided a lot of toolbox to remove our hassle to write the code from scratch, and we can concentrate on our research work rather than to write a script. So as here you can see, on pressing F1 we get a window which provides the explanation of GA function, like find minimum of function using genetic algorithm, and syntax. Here are various options which GA can enjoy, like if you will use the function GA, then you have to provide the fitness function and number of variables. Like in our case, we are having the 4 number of variables which are to be tuned, which are quality of service parameter here as defined. Yeah, our service parameter are time, price, availability, and reputation. The upper and lower bound are already provided in paper. The time is in between 100 to 2000 seconds. Price is 200 to 1000. I don't know it's in dollar or not, because it is not explained. Availability is this, and reputation is between 1 to 100. So this is the upper and lower bound of the random variable which is to be tuned, and because we are having 4 number of quality of service parameters, so the number of variable defined here will be 4. And like this, here we have seen we have defined the fitness function in this variable. D is the variable which defines the number of dimension, like 4, it will be 4 in our case, and option is provided, like here you can see these are options which are provided in GA toolbox, which will tell the GA that you want to plot the minimum, you want to plot the best fitness function in each iteration. What are the how many iterations you want to, how many maximum iterations you want to plot, and what kind of population you are having. Like if you we are using GA optim set, this is the function which tells you to create genetic algorithm option structure. Here you can see, so various, you can read this description over here. Various kind of parameters and their options are available, which helps us, like you want to create an user-defined function, then this is the method crossover function. If you want to define, although these all are having some default values, but if you want to change, if you want to use some other values from the different from the default values, then you have to mention these functions. In our code particularly, we have mentioned mutation function is the mutation adapt feasible, population size is m is the number of virtual number of physical nodes. Population type is our bit string, because we have to find out that this particular virtual machine is connected to which node, because not all virtual machine can be connected to each node. That will increase the cost definitely. So we have to tune in between them, that if we will connect this virtual machine to this node or this virtual machine to this node, then the cost is reduced considering our quality of service parameters. Okay, now here again we are using another option to plot the functions. We are using the best fitness function, best fitness value to plot and display iteration. It will display the iterations in the command window. Like if I will run, then you will see here some values in command window. That value is the that value generated because of this line. We are displaying the iteration values in each iteration here in the command window to get insight what is happening in the GA tuning. Okay, now let's start with the line one by one of our code. We are having main three files: main, MyOutput function, and objf. Main file consists of everything, like what are the input, what are the values of input, what are variables, and how GA is defined, how random search is defined. And the objfm is the lifeline of this work, because this is a fitness function which is defined in the paper. If you will double click on objf.m, then you will come to see how objfm is coded in the MATLAB and how it is compared with the equations defined in the paper. Like if you will see here, we need to find this value, which is the sum of this and this. So basically we are having quality of service from the main file. We have the we don't have DC from the main file. We have to calculate DC in the objective function. First, this is the distance from constraint satisfaction for a solution C. As you can see, DC is the multiplication of quality of service into EI into weight. Here we have considered the weight, sorry, yeah, this is the thing. The nomenclature is changed a little bit. Here you can see, as per the paper, you are multiplying quality of service with the EI. EI is the quality of service is less than 0, then 1. Here x. This x which is coming from the main file is the input to the objective function. The objective function is also called as fitness function for the GA optimization, and this x is in the form of, and it is in the form of 0 and 1 matrix. Later on I will see how you can check what values are passing, what values of x are passing here or not. And u is the global variable, because in MATLAB we are having two kind of variable. You must be aware, in every kind of toolbox, in every kind of language, we are having two kind. Local has the significance within that function, and global is having significance in various function where it is called. Like we have made the u as a global variable. U consists of the randomly generated quality of service values within this limit as defined in the paper. Low is having the lowest value of all these quality of service parameter, like time, availability, reputation, and etc., and up has the upper limit of this value. Okay, so here we have generated the values of upper and lower in random fashion as stated in the paper here. So it is mentioned in the paper that you have to generate these quality of services with uniform distribution from the following interval. The uniform distribution means that you have to use the pseudo random number, and rand is the function in MATLAB which fulfill this purpose. If you will select rand and press F1, then you will come to see rand is the function which uniformly distributed generate the uniformly distributed pseudo random numbers which satisfies the condition of this statement, uniformly distribution from the following interval. And we are using the interval stated in the paper for these all four quality of service parameters. And this uniform generated random numbers for these four parameters are called here in the objective function by using the statement global that makes the variable local variable to the global variable. And here you calculate the distance of these all four variables, and f denotes the first statement, f denotes the second statement in the fitness function equation, weight multiplied by dc, and this is the first statement. So here this is the sum. 0.0001 is the penalty factor we have used in our equation, and 0.0001 is the weighting factor which is used. So if I'll write here penalty, if you will write anything followed by ampersand, then that will consider as statement in the MATLAB, and that line will not be used in execution. Penalty factor is considered as 0.001, and weighting factor is also 0.001. Though it is not clearly specified in the paper what can be the value of penalty and weighting factor, so we chose the method of hit and trial for this purpose, and by changing the values of these penalty and weighting factor, you will notice a change in the interval range of the output. Though the nature of output will not change, only the interval of output will change. So it's a quite simple function which is just following the same objective function as in the paper, considering weighting and all these factors. Now coming back to the main file, there is one more file, MyOutput Function.m. This file is called in the genetic algorithm toolbox, and how it is working I'll let you know a little bit later on, starting from the very beginning in the code. Close all is the statement which close all with prior figure windows opened in the MATLAB. Clear all variables in the workspace here. As you can see, A, B, answer. If I press clear all, then everything will be cleared here. Until MATLAB is showing the BG option here, that means MATLAB is functioning and no other command and no other execution will take place until BG is pop up here. Now BG is gone, so you can see a terminal is ready to fetch another function left by the user. And see, we have used the clear all, that means all variables in the workspace are cleared now. And CLC is the function which cleared the command window. If I write CLC and press enter, then this command window will be cleared. Okay, this is just to make our MATLAB window user adaptable for the new work. We have defined here number of virtual machines, number of physical nodes, the number of physical nodes, and the lines in green color are all statements which don't take part in execution. These are just to mention what is the meaning, what is the significance of that particular line. I have taken care to mention to write the statement so that the confusion or any kind of discrepancy can be avoided here. Here we have made a variable u as a global variable, the variable which is to be made global, that has to be initialized initially, because after definition of variable, if you want to make it global, that would not be possible in MATLAB. You have to define it at the beginning of the code. And I told you earlier, low is the variable which have values of lowest value of all quality of service parameters in same order, like time, price, availability, and reputation. And up is a matrix which consists of the highest value of these four variables. Now here is the another thing, color map, HSV, these all things. If you see, if you want to know what is the meaning of color map, what this function do, you should keep in mind one important thing. The string at the left side of this equal sign is always a variable. Like at the left hand side we are having line color, up, low, D, M, N, line color, distance. These all are variable. These cannot be a function or anything else. Only variable are on the left side of equal sign. So there is no need to describe that what is the line color. Line color is itself a variable. You can change the name of variable as you wish. I selected to use line color to make it more explanatory, because line color is the color of graphs which are plotted later on. Color map is the function of MATLAB which generates a scheme of color. HSV is a scheme of color, that is a scheme of color, and how many colors do you want to generate from this HSV, you have to define. Like in our case we are using number of VMs 1 to 6 VMs, so we have to generate twice of these colors to make a visible difference between all these colors. Like if I selected the color map and press the F1, here you will see the description of color map. My system is a little bit slow, so it's taking more time to display everything. It's hanged, I must press again. Yeah, it's hanged. Now again, if I press F to see the color map, yeah, it's a set and get current color map. Color map default description is provided here. As you can see, color map is an M by 3 matrix of real number between 0.0 and 1.0. Each row is an RGB vector. RGB is the red, green, and blue vector, because as you know, any color is combination of red, green, and blue in different ratio. So this color map will generate colors by making a different ratio of this RGB color. Okay, and we have followed two schemes, HSV and Jet. We have this is just to make sure that how many number of lines we are plotting are of different colors. We don't lie that our color, we don't have much color to display the graph in different colors, and we have to display the graphs in same color. That will just create a confusion. Okay, now distance is another variable, and zeros is the function which generates a matrix of each element 0 of the size this length m. Length of n, like we have defined here, n is the number of virtual machines, so length of n will be 1 2 6 1 2 3 4 5 6 6 will be the answer of this statement. M is the number of physical nodes. So distance, a matrix named distance will be created with a size of 6 by 100, 6 rows and 100 columns, with every element with value 0. Now here loop starts for each virtual machine. Sorry. 4 is the loop is starting for each virtual machine. We are having 6, so loop will execute 6 times. Initially, the demand of each virtual machine is generated randomly. Basically, this is the quality of service parameters value to be generated in random manner. And here GA is starting. Our GA is starting. To calculate the elapsed time, to calculate the execution time, MATLAB provides a statement tick and talk. Tick and talk here, as I highlighted. Tick records the starting time of the line, and talk record the elapsed time, and we have saved this total execution time for each virtual machine in a variable execution underscore time underscore GA. Same is done with the random search also. Random search algorithm is denoted with RSA here, random search algorithm execution time. Okay, now since the fitness function is named as objf, so we have defined here a variable named fitness, which is having the name of the fitness function which we have coded in our script, that is objf. At is the handle. If you will see what at states, what at does, it just provides the handle to this objective function to the variable fitness. Right, so proceeding ahead, now there are some options as I discussed which is to be defined for the GA toolbox. What is the mutation function, what is the population size and population type. We are using the bit string like 1001 for the each population, so we have defined here its bit string. Mutation function is mutation adapt feasible function. We don't need to write what is the mutation adapt feasible. This is the part of theoretical portion, and because we haven't written any specific code for this function, so there is nothing much to describe about this function. MATLAB provides you the default code for this function. You didn't even check what this function is doing actually. MATLAB even don't provide the freedom to check its coding of any toolbox. Population size is m is the number of physical nodes as I stated, and population type is bit string in the form of 0 and 1, and you are plotting the functions, you are plotting the graph for each virtual machine, and that graph is actually the value of the best fitness in each iteration, and the all values of in each iteration are displayed in command window 2 using this functionality. And again I have used MyOutput function. You can GA toolbox also use the dynamical user-defined function, because if there is you want to use some other function and that is not defined in the toolbox, then you can even define your customized function and can call in that GA toolbox. Here what I did is the MyOutput function, because I wanted to display the graph of each iteration separately to compare with the random search. So, and in GA toolbox there is no functionality that we can get the output of best fitness value in each iteration in our workspace. So I created a function MyOutput function. That MyOutput function is here. It is taking the GA function at the input, and as you can say, state is the handle which is passed in this function. State.population is the number of population, and if you will see here, state.score, mean of the state.score is the mean score in each generation of the MATLAB, and that is saved. Save is the function that will save this variable in another variable. I have kept the name of this variable and this variable same. This variable will be saved here in the current directory with this here as a highlighted. This is because of this save command. Like if you have defined a matrix A, 2, 3, whatever, you will define A, and you want to save this matrix in the current directory, then just write save sd A. A is the matrix which is to be saved, and sd is the name, variable name, in which this A will be saved. Okay, if you will press enter further, you will see here SD is pop up that will contain the values, all values of A. Like if I clear, like if I will clear A and double click on this matrix, then you will see A is also again defined here. Okay, so this is the purpose. I have saved the iteration value to use it later on for the comparison purpose. This is the only motto to define this MyOutput function, nothing else. Now another thing is that we have used the GA. GA is taking the fitness function, number of dimension and options, which we have defined here in 3 lines. and in the output you will get the best value for best tuning variable value for which the cost is minimized, and this is the minimum cost value in the FL. Like if here I write x is the tuning variable values for which cost is minimum, and FL is the value minimum fitness function value after optimization. Alright. So after the tuning we have again called the saved variable load iteration value dot mat, and that value is saved in another variable fitness value for each virtual machine. This braces will enclose the variable for each machine. Like JJ is 1, then it will be saved in a form of cell at the first position. Then if JJ will be 2, then all iteration value will be saved in the form of cell at the second position, and so on. Okay, and here the again execution time of GA is saved. Now we in this editor we can put a checkpoint here. Like if I have put a checkpoint at line 34, then if I'll execute from here, the code will execute only up to line 32. It won't it will stop here at 34. So if you will like to see the output till 32, then just put a checkpoint at 34 and run the code, and you will see the execution is started because BG is here. Yeah, this is the fitness value. This figure, as you can see, this figure is the genetic algorithm optimization, and we are having almost 51 number of generations is done by this genetic algorithm, and mean fitness is plotted like this because we are doing the optimization to minimize the fitness value, so it should be minimized. And this is the method to evaluate any optimization algorithm. If you are working towards minimization of the fitness function, and then your method should minimize that fitness function at early as possible for the minimum number of generations. If your optimization algorithm can tune that can achieve a minimum value at 40 iterations and still it is going up to 100 iterations, then this is due to the lack of efficiency of the optimization algorithm. If your optimization genetic algorithm is stopped at 51 iterations, then this is a plus point of this algorithm, that it is not taking too much iterations to achieve a highest convergence position for the random tuning variables. In every kind of as you must be aware that whatever optimization algorithm you use, whether this is GA, whether this is random search or PS or any other optimization algorithm, it is started with the random position of variable and try to get to the position of minimum fitness value to get the stable values, to get the stable position. So as early as it will reach to the stable position, as early as it will converge, better will be the optimization. So as you can see here, fitness value J, the variable fitness value which is the main outcome of this program, fitness value you can see here in the workspace fitness value, and you will double click on this, you will get a cell. This is kind of cell which has further one, because we have just executed this program for the JJ is equal to for the one virtual machine. So you can see, if you will double click, you will see 51 values, and each value is like this. This one is the decreasing range of fitness function for the 51 iterations. The last one, excuse me, value is 0.1341. Okay, here again. So this was about the genetic algorithm optimization. Now we are switching towards random search optimization. We have to compare the genetic algorithm with random search, though we all know random search optimization is poor than genetic algorithm because it don't have any kind of regulation to put the agents in a space where the achievement of minimization is earlier. But in genetic algorithm we have chromosomes and we have the mutation function which direct the chromosomes to a particular direction, which to gain the solution as early as possible. But in random search we don't have this kind of functionality, and we have to just move on the basis of hit and trial method. In random search we use the same number of dimensions of the tuning variable: population size, fitness target, number of iterations. I have placed here the number of iterations 51 because genetic algorithm is also doing only 51 iterations, so I don't want to do more iterations than genetic algorithm, because to have a clear comparison between random search and genetic, the number of iterations should be same. So starting, and the same fitness function too. Starting tick is the command which records the starting of execution of random search, and again at the last we have used the talk which saves the elapsed time for the random search in the variable execution time underscore RSA. Starting from the number of iterations, we have generated the candidates randomly as in the genetic algorithm with the same dimension, and for each population size the fitness function is evaluated. Feval is the function in the MATLAB which evaluate the fitness function or any kind of function. As you can see, evaluate functions. This is the description, and it drives the syntax. You have to just give the function handle and the input variable which are required for the function, for the objective function. In our objective function we have only one variable, one input, that is the candidate kk, and objective function. Here I would like to consider a point here in your consideration. If you have defined a matrix, any matrix, random matrix of this one is a matrix, and if I say you that you have to access the element of first row and second column, then this is the way to do it: first row and second column. Get it? And we will place enter, you will get the first row and second column is 4, you will get the answer 4. If I'll say you have to access complete first row, then you just need to place the first row and comma followed by double colon. Okay, double colon means that you have to fetch all columns in the first row, that is 3 4 5. If I say you have to fetch all rows in the third column, then you will do like this, like all rows, so double colon, third column 5 4. This is the same thing here. Here candidate is a matrix of dimension, that is 4, population size, that is 100. So candidate is a matrix of 4 by 100, that is 4 by 100. Okay, so and we are fetching each variable one by one. So candidate kk, if kk is the 1, then all matrices in the all columns in kk row of the candidate matrix will be passed to the objective function, and whatever the cost of objective function, we will take the mean of this to consider that as the best fitness value for that particular iteration. And if that fitness value is less than the target, then we will stop here the execution. This is the termination condition of the random fitness. This is same as the genetic algorithm. That's why genetic algorithm is stopped at 51 iteration, because it reaches the minimum target fitness value and no further improvement is noticed after that. So here in the same is for the random search optimization. Our target is to achieve the fitness function value 0.1 if in each iteration, if in iteration we achieve this target, then it will be breakdown. Or if we are not achieving this minimum fitness function value as specified in the target, and we reached at the maximum number of iteration, then also this loop will be stopped. And the best fitness function value is saved in the RSA underscore fitness. This is again a kind of cell structure. And if I will put a break point here at 52 and will continue, then you will see RSA underscore fitness again 51 and with the values of different, because it don't have any regulation over the random generation. So you will see it will be having a random pattern, not a decreasing pattern in the later on plotted graphs. Okay, this till now this loop has executed for the one virtual machine. Now if you will have two virtual machine, then just this is for the second virtual machine, genetic algorithm optimization, and for the RSA2. Now I must remove this breakpoint to let it execute smoothly for all virtual machines, for the 3 virtual machines, for the 4 virtual machine, 5 virtual machines, 6 virtual machines. Now our cursor has reached here. Now we have optimized the RSA, we have optimized for the GA for same kind of values, for same kind of physical nodes, for same kind of quality of service upper and lower range. Though because we are generating the quality of service values randomly, so every time you will call rand function in the MATLAB, you will get different values. Like if I will state right here rand, you will get different value 0.3308. Again if I am calling rand, you will get a different value. Again you will get different. So this is the main property of rand function, that it is pseudo random. Random itself states that you will get every time random number. So whenever you will get different results from my results because of this property. And this is the property which makes the optimization, every optimization algorithm, not accurate but approximate. Okay, got my point? Now here in the next for loop, you are just plotting all fitness value of GSA and RSA. Now fitness underscore value is the fitness value of genetic algorithm, and RSA underscore fitness value is the fitness value of the random search algorithm. And we are plotting. Plot is a command in the MATLAB which plot the figures, which plot the graphs, and hold on is the function just to plot two different graphs in a same figure window, so that we don't have to generate another figure window, and we don't need to full our MATLAB window with different number of figure window, which are unnecessarily make this MATLAB window messy. Okay, so fitness value, because we are having we have executed the code for 6 virtual machines, so we are having 6 cells. Here you can see fitness value is having 6 cells, 1 2 3, and we will plot each cell one by one, and our for loop will also again execute for 6 times. So fitness value and RSA underscore fitness is also of same dimension, 6 cells. And this is the property of plot, that the color of the line we can choose here. We have line color. I have already specified that color map will produce different kind of colors of this value, but 12 into 3, because we are having 6 virtual machines, so we have to generate 12 different colors, because the color are the combination of R, G and B, 3 different colors. So first column is for the red, second column for the green, and third column for the blue. Here is a color which is made up of red, green, blue. Green and blue are 0, so color will be red. This is the combination of red and 50% of green. This is the combination of red and green. Blue is 0 here. So different combination can be here. And again line color 1. This is for the HSV color scheme. This is for the jet color scheme. These are different kind of color scheme. No need to discuss in detail what is HSV, what is jet, because it is a part of computer graphics. And this is the property, another property of plot function. This is line width. The width of graph line, what should be the width of graph line? That is 2. You can make it 10 to look it more bold. Okay, y label is the label on the y axis, x label is the label on the x axis, and whatever label you want to define, you have to define that in single inverted comma. Title is the name of the graph which you want to plot, and legend is the entry on the figure, graph figure, that is on the right top right side, that will define first graph, what is the name of first graph and what is the name of second graph, and all. Like, see, if I plot all these graphs, you'll see, sorry, see, this is the genetic algorithm objective function calculation for test case 1. You can see GA fitness function is of this color. I don't know the name of the color because there are a lot of colors, and RSA fitness function is defined here. As I told, RSA is don't have any kind of regulation over the candidate generation, so the nature of this is very random. We cannot predict that RSA will optimize the objective function or not, because it's you can see it's very unpredictable. Somewhere it is going higher, then down, high and down, high and down. But in genetic algorithm, we have a decreasing value of fitness function, which is our desired result. For the test case 1, you can see the range and all these iterations. Again for the test case 2, again for the test case 3. You will notice one thing, that in every test case our genetic algorithm is performing better than RSA fitness value, because, and this one is our motto, that GA is better than RSA in terms of optimization algorithm. Even RSA is not able to optimize within this 51 iteration. Maybe it can optimize up to 200 iteration or 300 iteration, but up to 51 iteration, which is the plus point of GA, that with the less number of iteration it is giving the more sophisticated result, more convergence of the fitness function, which is not which is absent in the RSA algorithm. And again this figure window, again in the figure window, like we have plotted here to 8 window, in 9th window the execution time will be plotted, which we have saved in the variable for the GA and for the RSA to make it, and you can see here for the execution time is increasing with the number of services. Okay, GA and RSA, GA is having the less execution time as compared to RSA. Okay, this one is the explanation of complete code which I have provided from my side. If you have any kind of doubt, or any query, you can reach me on our messenger. Thank you.